So let's conclude this short chapter with some details. This is now going back to our urban heat island effect. So we are looking here at a place with normalized difference built up index. So this is showing how much of this particular city is built up. Okay, so goes as a range from minus 0.77 to 0.98. It's a normalized difference, so it's a way of doing things using satellite data of various spectral bands to identify natural vegetations and land use versus built up areas. And the better known index, of course, of this type is the so-called Ndvi, normalized difference vegetation index, which is used a lot for studies on carbon land use and so on, which I'll show in a minute. So this map is another one which is showing non-built up and built up areas. So this is a normalized difference built up index, and this is just identifying binarily built up and non-built up areas. So you can see the correspondence here between low NDBI and the non-built up areas, high NDBI and built up areas, which is what you would expect. What is the point of this? The point is that now quantitative aspects of determining physical and social vulnerabilities focus on environmental variables like temperature, precipitation, land use, etc., with social vulnerabilities, which we will look at a table. And the point of this kind of high resolution map is that the vulnerabilities in fact do depend on whether you live here in the middle of a non-built up area on, let's say, close to what seems like a stream that's running through here, I hope, and versus much more densely built up area, in addition to the socioeconomics in terms of per capita income, whether you work outside, whether you have to travel for work by public transportation, or you have your own vehicle, and so on and so forth. So NDVI is shown here. So this is showing for the ocean chlorophyll A, which is a measure of photosynthesis in the ocean, and on land this is showing what is called normalized difference vegetation index. I'm not going into details of how NDBI and NDVI are computed because we are more focused here on how we will combine the physical environmental data with socioeconomic data to produce risk maps. So let's leave these details for another time. Okay, just to make a point here, along the coast where you see lots of high chlorophyll, for example, especially here where the rivers come out, like the Congo Zaire, Amazon, Orinoco, or the rivers Irrawaddy, Ganga, Brahmaputra, and so on. These are also hotspots for harmful algal blooms, pathogens, and now with ocean warming and coastal pollution, the number of regions with low oxygen and high harmful algal blooms and pathogens are increasing, like the Gulf of Mexico or the Mediterranean coast all the way into the northern regions here, up to Norway and so on. Okay. These are the kind of physical variables that would go into finding the relations, and the methods mentioned in the book is called PCA, Principal Component Analysis, which is like empirical orthogonal function. Again, without going into detail, if you have, let's say, an array of data, temperature at latitude, longitude, and time, then the matrix has 3 dimensions: latitude, longitude, and time for temperature. EOFs and principal component analysis basically extract spatial patterns that are dominant. For example, if you take sea surface temperatures and make EOFs or PCAs, you will get an El Nino pattern with spatial loading that's high in the East Pacific, where the El Nino predominantly occurs, and you will get a time series, which is the principal component, which can identify years where El Nino and La Nina happened. They can also extract trends and decadal variabilities and so on and so forth. So you can read up more on PCAs and empirical orthogonal functions. Quickly then, vulnerability variables for socioeconomic and environmental include things like this. These are input variables, social and physical, for vulnerability assessment, tested against a dependent outcome, mortalities during the heat wave. So vulnerability has to be done for something, for food, for disease, which disease, and so on. This is particularly done for mortalities during heat wave, to designate which variables were the best predictors of risk. Okay, so here in the US, it would look at total population of population and white alone, black population, American Indian, Alaska Native alone, Asian and Native Hawaiian, other Pacific Islanders, let's say, and age groups. So the vulnerability also depends on how old or how young you are. Older than 65, you are more likely to be vulnerable if you go outside, or if you're living by yourself without support structure, if you are poor, don't have AC, don't have help, and so on and so forth, or you are not getting information about the heat wave, and so on and so forth. So households, median household income, poverty under 5, 65 and up, and environmental parameters like mean temperature, normalized difference built up index, and normalized difference vegetation index, which tell you how the urban heat island is going to affect your particular neighborhood. You have to get very local. Okay, the same thing done for India would have many more categories: permanent employment, temporary employment, caste, because that tends to affect your socioeconomic status, rural versus urban or peri-urban, migrant labor, and so on, and type of housing you have, whether it's a building, whether it's a slum, and so on and so forth. Okay, so not only are physical conditions very local, region specific, but also vulnerability parameters that you have to consider with respect to any particular disease also have to be very local. Okay, so here are the physical variables. For example, land surface temperature in Fahrenheit. I think this is Chicago. So similarities of the remotely captured physical variables, city of Chicago. Okay, so you can see how non-uniform the land surface temperatures are, and here is the normalized difference built-up index. You can see again variabilities in vegetation cover versus density of buildings, which relates to density of people and typically to socioeconomic status as well, and normalized difference vegetation index, which obviously has a correspondence and has relation with land surface temperature as well. So this is kind of the physical vulnerability parameters. So there are predictors and there are predictants. So you take physical variables and vulnerabilities and you produce heat wave vulnerability map here. So remember, it was about hazard, exposure, and vulnerability, and of course there was also resilience. A heat risk vulnerability map for Chicago 1990s. City-sponsored cooling centers are also identified on the map in these blue dots here. Why does it matter? Because once you have a risk map like this at local scales, then you know where to put the cooling centers, right? That matters a lot. You don't need to put it in rich neighborhoods, for example. Okay, centers that are in higher risk areas should be considered priority locations for activation during oppressively hot weather. Okay, so we didn't go into the details of how the vulnerability index was computed, but those are the parameters that go into it, combination of socioeconomic and environmental parameters, and the data is available at scale so that such high resolution map for the city can be done. So you can see here vulnerability risk by census tract, high, medium, low, and so on. And recorded mortalities are high in the high risk areas and then drop off towards low vulnerability risk areas. So this is the key point of this chapter. And the other thing we have to add is that now looking at a map of the heat wave that's swallowing up the northwest US and Canada, Enormous new records are being set here. For example, daily maximum temperatures in Seattle and Vancouver. This is for the period of 1979 to 2021. The maximum temperatures you got were around here, 100 degrees. The last 3 days during this period when the report came out, they are all way out of the range of anything that has been seen over these several decades. Okay, so the question, of course, is this related to climate change? Of course it is. Attribution studies are done now, I think. At least scientists have reported that this is related to the so the intensity of the heat wave has been increased by climate change. Okay, so you can see that there are periods where heat waves occur, but the intensity has been exacerbated. Now the question is whether these will occur more. Already reports are out saying that such heat waves will occur more in this region. Plus now a new heat wave has taken hold here in the southwestern United States. Okay, so this region in general during a La Nina, without going into too much detail, is dry and hot. And now with global warming, if the pattern in the tropical Pacific looks like a La Nina, this region is going to continue to remain dry and hot, and then you are going to have additional overlapping of seasonal means versus heat waves with specific patterns like the heat dome that formed here, which can really create these deadly heat waves. Okay, so again, vulnerability and risks have to take into account these, and remember that those are not stationary maps. They have to be updated regularly as physical vulnerabilities increase and see how socioeconomic vulnerability is changing over time. For example, rich people may just move out of the areas if heat waves become very common, leaving behind other social problems like lack of employment or just poor people fending for themselves, government services getting worse potentially because tax base disappeared, and so on and so forth. So everything has to be considered when we talk about planetary health. We cannot just talk about physical and social vulnerabilities at one particular time or at a large scale. We have to talk about local scales and how every factor is changing over time and what is expected into the future. Okay?